Hey folks, welcome back for another episode of Code Club. I am Pat Schloss. I'm a professor at the University of Michigan, just outside of Detroit in the southeast corner of the state. I am grateful to have you all joining with me this morning for this live stream. And let me show you what we're going to be working on today. Let me kind of get my buttons right here. But you can see over on the left is a page from the journal Nature Microbiology. The title of the article was Initial Sites of SIV Rebound After Antiretroviral Treatment Cessation in Rhesus Macaques. And so you don't really need to know what any of that means, except if it helps, give some context. This is a model system for studying HIV, which is a deadly human disease that is treated by antiretroviral treatments, right? And so the question then is, if you stop taking this treatment, what happens to the virus? Where does it disseminate to? And so the figure that I'm most interested in recreating with you today on this live stream is from figure 1. You'll see that it doesn't really have a very declarative title, but that's okay. We're going to be looking at panels D and E. And so there are 4 real sub-panels here, right? And what I'd like to do is to turn this into one panel. So it'd be like panel D, but it would be basically the same amount of real estate that these D and E take up, but with one labeled subpanel, okay? And my goal then is to make the plot more interpretable. So let me go ahead and put a link to this article here in the chat. And I see people are saying hi already this morning. Awesome. Please go ahead and tell us where you're joining from. I see we have Hassan from West Virginia, Mike from the UK, and John from Barrington. So wonderful. Thank you for joining. Hopefully get a lot more people join. I see we've got about 10 people watching right now. So hopefully that number keeps going up, and hopefully people will keep telling us where they're joining from. So I put in the link there to the article, and great, we've got Mark from South Africa. So wonderful. We've got Africa represented as a continent. So that's awesome. It always amazes me how wide of a spread and just diversity of locations geographically this channel goes out to. Far bigger impact than I can have here at the University of Michigan, which just I think is pretty awesome. So anyway, on Monday, I released a video critiquing this figure and talking specifically about panels D and E and how I would think about recreating those, right? And so if we look back at the paper, and let me find figure 1D where it's referenced, right? And so this is, in a section called Use of Barcoded SIV, blah, 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 right? And so there's a sentence where panels D and E are described. And I believe this is the sentence. And they have some very long sentences in this paper. But basically what they're saying is that if you look at D and E, the top panels, subpanels are DNA, and the bottom subpanels are RNA. And they have then different body sites indicated by the different colors. They've got blood over here in D, and then they have 7 other body sites or tissues in panel E. And so what they're saying is that that there's high levels at day 12, right? So that's this first time point, right? So high levels. And then on ART, so when the animals are on the therapy, you see a decline of 3 to 6 log 10 copies per million cells for vRNA, so viral RNA, right? And only a 1 to 2 log copies per 10 to the 6 cells for viral DNA, okay? And so basically what they're saying is that if we look at the RNA from day 12 to say 21 and 66 weeks post-infection, we see a 3 to 6 log drop. So that's 1,000 to 1,000,000 fold drop from 12 days to these other time points. That's RNA. For DNA, they said it's a 1 to 2 log drop, right? And so again, from like day 12 to week 66, that here in this case, at least looking at the mean or median, I believe it is, that's like a 1 log drop, but I can imagine that from that point to this point, maybe that's a 2 log drop. But that's kind of what they saw across this. And so my point in that critique video was that that is actually harder than it needs to be to see in this figure, right? So panel D, it's very easy to see that, right? Because the time points for the blood are right next to each other, right? But if we go over to E, and I want to say look at peripheral lymph nodes, PLN, then I've got this at 12 weeks. Over here is 21, and over here is 66. And it is, well, maybe I can see that there is a drop here. I guess going from 21 to 66, it's a little bit harder to see. But then I have to keep doing that for each of these 7 body sites. And so my suggestion would be to replace this with something that I have on the thumbnail, but basically is like what we have in D. So to basically across the x-axis to put the 8 different tissues or types of samples, and within each of those 8 sites, we would then have the 3 time points. Okay, and then on the top we'd have DNA, bottom viral RNA, right? And so what that would do then is that we would have, you know, basically right next to each other, peripheral lymph nodes, bone marrow, duodenum, rectum, liver, and within liver then, I could see the 3, you know, sets of points right next to each other. So I wouldn't have to be like, okay, there's liver, here's liver, here's liver. How big of a drop was that, right? Like that's just asking a lot for your audience to be able to make that type of interpretation quickly. And that's far easier to do it when we put across the x-axis the type of sample, and then within that have the time, okay? So that is the plan for today, is to take this data and refactor panels D and E into one panel that on the x-axis has the body site, and then within each body site has a time point. On the top, like they had, we'll have DNA, the bottom RNA. The other thing that this will get us is that they have 8 different colors here, right? If you include this kind of, I don't know what color that is, pinkish color for blood. And they also have a whole bunch of different shapes. And so I think we can get down to like 1 shape and maybe 3 colors, right? So maybe what we'd want to do over time, so we have these 3 time points, would be to have like white for 12 days post-infection and a darker color, a fully saturated color, like blue or black for 66 weeks post-infection. And then for 21 weeks post-infection, we could have a shade in between white and black or white and blue, okay? And I think that will really help to simplify the appearance of the figure. So let's see if we can do this. My goal, as always, is to finish this within 2 hours. We'll see if we can do it. But I pick these figures because they're interesting to me, but also because they're in open access publications. So you can get this article for free. Again, I put the article over in the chat link. Also, one of the things I like is if they make the data publicly accessible, right? So there's this link here for source data. I'm going to go ahead and copy that address, and I will throw that here in the chat. All right, so that's there. Great. And I see we've got Mark joining from England as well. And so, yeah, so great. Thanks everyone for joining. And as I go along, if you have questions or if you have ideas, feel free to holler in the chat, right? That's why I do these live, is because I get that interaction with you all. And I'm always looking for more types of interaction to have in these streams, okay? So let's head over to our studio. And I want to go ahead and, let's see, what am I doing? So I'm gonna go to my files. I didn't quite have this set up before I got going here. So in my desktop, and oh, I've got way too many things on my computer. Oh, sorry. Right, this is not, all right, Civ live stream. I already created a directory for this. I'm gonna go ahead and create this as my working directory. And so then what I'm gonna do is save this untitled file into my working directory, and I'll call this civ jitterplot.r. And as always, if you wanna get the code that I'm generating today, then at the end of this live stream, down below in the description, I'll put a link that you can go to get that code. And so I really hope that people find that code helpful, because maybe you're not trying to make this exact same plot or set of plots, but you want to see, well, how did Pat do that thing, right? Let's go back and look at his code to understand how he did that for that application so that I can then use it in my own application, okay? So we'll go ahead and do library tidyverse, because I know we're going to use the tidyverse and all its glory as we go through here. And I've copied that link to right here. And I'm going to say this is my data URL. And I'll go, and I did put that link in the comments, so good. And we'll go ahead and do download file. And the URL is data URL. And then the dest file is going to be, I'll call it figure1 data.xlsx. And don't yell at me for working in Excel. That is how Nature posts this data to their site, okay? And so I've downloaded the file, and you could say, well, you could have just clicked on it and then it would show up over here. Oh, maybe I have to refresh it. Yeah, there it is. And done that way, right? But what I'm trying to do is get this to be computationally reproducible. So you could get this script and run it, and it would download the file to your working directory and output everything to your working directory. Okay, so let's come back to my Finder then. And if I come to my Civ jitter plot, I want to get a sense of what figure1 data XLSX looks like. And sometimes Excel is a little bit slow to wake up in the morning. Well, that's a problem. Maybe I have the wrong URL. Let's see. It's complaining about something. Oh, I know why. Because I put a link to this page, right? Which is not what I want the link that's here instead. So I put the wrong link. So I'll go ahead and try this again. So let's do copy link address, and oh no. So let me paste that in. Okay, that's the Excel workbook. Very good. And so now let me come back in here and paste that in. And so yes, the correct URL has XLSX in it. We'll go ahead and re-download that. I guess in this case, if I would have just clicked on the link, I could have seen what it was trying to do for me. But anyway, all right. So we'll go ahead and open this up. That opens. And so we can see the tabs, right? Figure 1B, 1C, 1D, 1E, 1F. So this is 1D for the blood. And then 1E looks like this. They're formatted a bit differently. And so one of the challenges in these live streams, as always, is getting the data out of Excel, right? So I'm going to start with figure 1E and build out figure 1E, and then we'll come back and add the 1D data. And I'm going to do that just because this looks more complicated. So let's start with the hard thing first, right? Maybe I'll make this a bit bigger so you all can get a sense of what this looks like. And so just kind of trying to look at the structure of this to understand what's going on. And I think if I come back here and then I do read Excel, and I need to load that library read Excel. So library to read Excel, like here I have on line 2, is it actually installed with the tidyverse. So if I do read Excel, and then I do this as my destination file, and read that in, then what this reads in is the first page, which is for figure 1B, right? And so what I want is sheet, and just remind myself, say figure 1E. So we'll read that in, and we might expect that this is going to look pretty funky, right? And so if I look, I see I've got figure 1E up here in A1, and then I've got a whole bunch of blank stuff, and then on subsequent rows, it's just kind of formatted gnarly, right? So I encourage people, when you're working in Excel, to start in cell A1 with your data. Don't do this cell merging garbage. It looks pretty, but it's really hard to work with computationally. All right, so what we will do is I'm going to start up here in B5, and so I can specify the range of cells I want to get, right? So I can say range equals B5 colon, and then that will come down here to cell W28. W28. Read that in. And so this then is using the wrong column headers, right? So it's using that first row. But other than that, it looks pretty good, believe it or not, right? And so we need to get column names for these columns, right? And so we can then add that in here. We could do like call names equals, I'll say call names, right? And so I need to make something called call names. But for now, if I do like call names equals letters, how many columns are there here? So there's 3, 6, 9, 12, 15, 18, 21, 22. So we'll do 1 to 22. And so we should get the column names now being the first 22 letters of the alphabet. And that's sure enough what we get, right? And so before we go on, let's go ahead and make those column names. Let's make that vector, because we're going to use the same vector to read in the bottom table, right? So the top here is DNA and the bottom is RNA. So we're going to recycle that for both the top and the bottom. All right. And so again, we've got these 3 time points. So I'll do like times, and I've copied and pasted that in. And so these are going to be characters. And I'm not sure what that red dot means, except that that might be some funky character that I want to replace with a actual space. So I'll go ahead and do that. I've never seen that before. I wonder, I don't know. Sometimes when you hover over things, it'll tell you why it's formatted the way it's formatted. So that's our times, right? And then we're going to have sites. And these are our sites. And again, we'll do the same type of thing. I've copied, and I suppose I could have typed things out, but I don't know. In some cases that takes longer. So I'll go ahead and just manually edit all this. And the main thing I have to do is to wrap my individual sites in quotes and then separate them with commas. And I'm also going to write out the abbreviation. So you'll notice already that like in the original figure, they had BM for bone marrow or DUO for duodenum. I'm going to do the same thing for these lymph nodes here. And I kind of screwed up. All right. So this is going to be peripheral lymph node. And then this is going to be mesenteric lymph node. Okay. And let's go ahead and get that to wrap. And we might have to put in a line break at some point when we go to make our labels, but that should be good. So we now have times and sites. All right. And we could also then do expand.grid. And let's do sites, comma, times. And so what expand grid does is it will give me all combinations of these, right? So I've got 7 sites, I've got 3 times. There are 21 possible combinations there, right? And so we can see that we have peripheral lymph node, 12 days post-infection, mesenteric lymph node, 12 days post-infection. I want to flip this because it's sorting things. I want to have peripheral lymph node 3 times with the 3 different time points, right? So I wonder if I do it the other way, if that will give me what I want. So if I do times sites, good. That gives me peripheral lymph node 3 times with those 3 time points. And so what I'm going to do is I'm going to say this is time, and I'll say this is site. And so that gives me, for now, just a pretty, that gives me a pretty label. And I think what I'll do is I will go ahead And I'm going to combine these together to make a label, right? That's going to be my columns thing. And so I could do that with glue, or I could do it with paste 0. I think I'll do it with glue because I feel like glue is a little bit more elegant than paste. So let's do that. So I'm going to take this and I'm going to mutate to make a pretty label, as I often do. And this will then be glue. And for no particular reason, let's go site underscore time. And so then the column names, the way glue works is that you give glue a string, and within that string, you can put variables and you can put regular text, right? So like what this means is take the data from the site column and join it to the data from the time column, and between them put an underscore. And so I'm putting an underscore in there because at some point I'm going to want to split these apart, right? Because the data is currently wide if you look at the Excel workbook, right? And at some point I'm going to want to make it long, where I'm going to want a column for the site and the time. And so by putting that underscore in there, it'll just make it easier to split that apart later. And so this then gets us our pretty label, right? And so now what I'm going to do is pull pretty label, right? And so then this gets me a vector of my pretty label. And I'm going to want to put this in here to call names, right? And so maybe I'll call this sites times. And then here for call names, I'm going to do animal ID, and then sites times, right? And so then if I look at this vector of sites and times, and animal ID needs to be a string, right? Because that's going to be the name of that first column, where sites times is a vector of those strings. And so now you can see what the different column names are going to be, right? I've got animal name up there at the top. And so now when I do this read Excel, finally, right, we get those column names. So that's cool. I'm going to pause there, and maybe we'll call this DNA. Or actually, that's DNA. Okay, now we want to do the same thing, but for RNA. And so the only thing that should have to change is this range down here, okay? Great. And so, again, we'll start up here at B33 and come down to W56. So B33, W56, and let me double check I did that right, 33 and 56. And actually, as I went down here to look, I'm noticing that they've got NA values in here, right? And so that ND says not detectable down here in the lower right corner, so below the limit of detection. So it's not really a zero. I'm sorry, it's not an NA. It's more like a 0. And so it's below their limit of detection. And I talked about this in talking about their figure, right? The critique, that these points down here in these rectangles are the values that are below the limit of detection. And when they calculated their medians, they did not include a limit of detections. And we'll see that here in a moment. I guess one other thing that I'm going to point out here that I'm going to do is I'm going to make a single y-axis rather than pulling apart things in this box, okay? And so I'll have to think about that ND here pretty quickly about how I'm going to deal with that, because I believe those columns are going to get turned into character when I read them in here and look at RNA. Okay, so RNA then, if I look down here, like this spleen 21 weeks post-infection, that's a character. And so if I look over here at spleen 21, there's an ND here. And so that ND turns that whole column into a character, because it's a character, right? And so what I could do is I can actually add a argument NA to set the value of ND to actually be an NA. And then later I can turn that NA into a 0, okay? And so let's then do ND for that. And we'll do that for the RNA data frame. And I think I forgot to run it for DNA. But now if we look at RNA and we look at that spleen 21 weeks post-infection, now it's a double, right? Okay, so Now what we'd like to do is go ahead and join these together. And what we can do is then bind rows, DNA equals DNA, RNA equals RNA. And this should make a single data frame. It does. We've got 48 by 22, whereas before they were, I think, 24 by 22, right? But I don't have a column for the nucleic acid type, right? And so the argument that I can use is .id, and I'll say nucleic acid. And so now I see I have a first column that's nucleic acid, right? And so I want to pause here and just point out we've got a data frame and it's wide, but perhaps we can begin to think about that. We're pretty close now to being able to make it long and then throw it into ggplot. Okay, so we're almost there. I do want to add in the blood, right? And so I'm going to leave this here, what I've got already, and I'm going to maybe do the blood separately and then think about how I can bring in the blood. All right, and so let's come back, and that's going to be figure 1D, and I'll probably grab this, and it's going to be figure 1D, and the DNA range, let me make this a bit bigger so you all can see it, is here. And I'm noticing that this actually has the time in the column, right? And so maybe I could start at B4 to E28, B4, E28, and I don't need the column names. I do need that NA still. So if we run this, this reads it in. We get our animal ID and the weeks post-infection. And ultimately what I'm going to want to do is I'm going to want to join this data with the rest of the data I already have, right? And I also want to think about kind of the ordering of things, but we'll get there in a minute. So let's go ahead and repeat this and get the RNA. And so again, that's going to be changing the range. And so that's going to be from B31 to E55. So we'll do B31, E55, and we've got that. And here we can see more clearly how these values, the ND, non-detected, were turned into NAs. And good. And so let me think how we can do this easily. And maybe, let me think. Maybe what I actually want to do is back up here with DNA. I could read in both the blood and the tissue DNA and join that together on the animal ID column, okay? And that way then I could have my blood data and then the rest of my data, if that makes sense, right? So let's come back, and I'm going to pull this up a little bit. And again, there's many ways to do this. I'm just going to kind of talk through how I would do it, right? And so one thing that I'm seeing is that I'm going to use different column names perhaps than what they gave me. And so I'm going to have to start then at B5, so the fifth row, and then put in call names, right? And that's going to be glue. And then we'll say, I'm going to say peripheral blood because that PBMC is short for peripheral blood. I forget, it's in the paper, peripheral blood monos something cells, mononucleated cells, right? And so I'm going to say peripheral blood. And so let's do peripheral blood. And then I'll do the underscore, and then in curly braces, I'll do time, right? And then we'll want that NA. And so now when we read this, times, all right, times. Sheet 3 has 4 columns. 4 unskipped. Oh, but call names only has length 3. And that's because I forgot the animal ID. So we'll do C animal ID with that. And we need a close parenthesis here. Bring that in. And we're good. Great. And so now we can see we've got the animal ID and all that, right? Cool. So we want to join these two calls together. And so I am going to do an inner join on that. And the rest of this, and maybe there might be a lot. It might be a lot to put into one function, but I think it's okay. There's no need to make extra names if we don't need to make extra names. So let's go ahead and put this down here then. And that's good. And we're going to join by the animal ID column, right? And so I'm putting the blood first so that those 3 blood columns go first before everything else, right? And so now when I run this, I see that I've got animal ID, the peripheral blood, and then I've got the peripheral lymph nodes and all the other stuff, right? And so this then I can call DNA, and probably just tab this over a smidge. All right. And so now we want to do the same type of thing, but for the RNA, right? And again, the thing that's different is going to be the ranges. So I'm going to copy this down here, and we're going to call this RNA. And so this range, right, goes for the second set of data here. I guess the other thing that's different is the tab, right? So we've got that. And so now I need to change this B5E28 to what it is down here. And so that's going to be B32 to E55. So B32 to E55, okay? And so let's look at this just to make sure it all works. And that looks good, I think, all right? And so now I can remove this line of RNA. And I now have my DNA, my RNA, and then I can bind those together and look. And we've got nucleic acid, animal ID, and we start with peripheral blood, and then we move on out, right? And so what I could do would be to like take this and pipe this to call names. And I see all of the different column names that I have, okay? So let me take a pause, take a drink, think about what I've just done here, see if you have any questions, and then we'll move on with the data to making the plot. All right, so I guess I don't need this read Excel down here. So we've combined the data frames together, and as I said, it is wide format. And so now I want to do a pivot longer, and we will do, the calls will be everything but animal ID and nucleic acid. And we'll do names to equals site time and values to, and we'll say density, okay? And so now what we have done through that wonderful command is we've taken what previously had 26 columns, and now we have 4 columns, and instead of 48 rows, we now have 1,152 rows, okay? So we've made it long, and we can begin to think about how we're going to plot this, right? So we're going to facet by the nucleic acid. Each point is going to be a different animal. The density is on the y-axis. And kind of think about here also that we've got the site and the time are concatenated together. So we need to split those apart because the site we're going to want across the x-axis and the time we're going to want to be across within that site, okay? So we'll come in here then and we'll do separate wider delim on the site time column. And our delim, I got an extra space in there, is going to be the underscore, right? So that's that underscore that I built into that site time name. And then we are going to do names, and we'll do site and time. And so running that, we now see we've got 5 columns, and we have that site column and the time column, okay? Cool. So one thing I am remembering is that my density column has NA values in it, right? And so one thing we might do would be like filter is.na on density, right? And so we see that we've got 91 values where density is NA. And what I'd like to do is I'm going to start by changing those values to 0. And we'll revisit that later. Or actually, let me look at the plot, because the plot is on a log scale, right? So we can't use 0. And so I think what I'll maybe do would be to put it at like this bottom edge. I could imagine being like 10 to the minus 2. And in the middle here, maybe like 3 times 10 to the minus 2. So let's do that. So we'll do mutate density equals if else. And I'll say is.na on density, right? So that's basically these values. If it's an NA, then I'm going to do 3e to the minus 2. And then otherwise, I'm going to use the density that it already is, right? And so now when I pipe that to this filter, well, there are no NA values, right? Cool, all right? So we've gotten rid of those NA values, and we'll come back and we'll probably have to modify this later because we're going to have a bunch of points all at the same line. And if you look at theirs originally, kind of down here where they have multiple points, they jitter those vertically as well, okay? So we'll come back to that. But now we have all our data, and we are ready to start plotting. So let's go ahead then and do ggplot, AES, across the x-axis. Well, let's do site, and y, let's do density. And then I'm going to do fill equals what? Fill equals time. And we're going to use that shape 21 that has a black edge and a colored fill. So let's go ahead and do geom jitter, shape equals 21. And then we're going to want to facet. So let's do, for now, facet wrap. And we'll do tilde nucleic acid. And we'll do n row equals 2. Okay. And let me hide my face. And, well, that's a bit of a mess, but we can see mostly what I think we want to see. Let me bring up the original. And I think part of the problem with the DNA is that those values are generally about 2 logs lower than the RNA. And so we'll want this on a log scale. So let's go ahead and do that real quick. So we'll do scale y log 10. And so now we can see that we have, we have data, right? And maybe what we want is, and we can see these are NA values down here, right? So that's okay. One thing I'm noticing with these points is that they're jittered, but they're on top of each other, right? And so one way we could deal with that would be to do like position equals position jitter dodge. And so now what we see is that we have our points. They're jittered, and I can already tell they're in alphabetical order, so it's messed with my ordering here a bit, but we'll come back to that. But now we can see, hopefully already, that this is going to be easier to interpret, right? So if the red and green is 21 and blue is 66, then I can easily kind of scan across these, and for each site very easily see that there's a fall off between 12 days and 21 and 66 weeks, right? So hopefully you can already start to see this, right? All right. So hopefully, I wonder if my internet dropped and picked back up again. I think we're back. So I see Mike says you could use replace NA. Let's do that. That sounds interesting. So if we do density equals, I'll comment this, I'll copy this down. And let's go ahead and comment out that line. So density equals replace NA. So the data I want will be in density, and I want to replace it with 3e to the minus 2. Okay, so let's see if we get the same result. Yeah, we get the same result. So that works, okay? So I had a little bit of a gap with my internet. If someone could just say hi in the chat, and I know there's a lag between the chat and me recording. So if you could say something, that'd make me feel better that I'm not just talking to nothing. So anyway, there's a storm outside. I don't know if that's having problems with some of the internet issues, but anyway, I think we're good. So thank you for that suggestion with replace NA. I think that's a lot simpler syntax. Cool. All right. So let's go ahead and think about what we want our figure to look like in the actual dimensions. So let's see. I have in my terminal the original. So that's my figure 1D original PNG. So if I do like file on that, I can see the dimensions here, right? And if I come back to the page and look at the PDF, well, I know it's 7.5 inches wide, and I'm gonna say this is taking up, let's say 5 inches, 5.5 inches of that 7.5, right? So we'll say that GG save, figure 1DE, maybe I'll just call it figure 1D because I'm gonna combine them together, and we'll do width equals 5.5, and then height is gonna be based on this aspect ratio, right? So I'm just gonna be 5.5 divided by 21.56 times 1738. So we'll say a height of 4.4, right? And that's going to be, the default units is in inches. So let's go ahead and save that and then open it up here. All right, so that's what we've got. And then if I look at the original, well, let me kind of scale mine down a little bit. All right. So we can see theirs and mine. And again, I'm trying to kind of do a drop-in replacement for mine versus theirs. And so, like I was saying, I think we can already see that this is going to look better than theirs. Yeah, I think that's true. And so maybe the legend for now I'm going to drop. And so let's see how wide we get with that. So I can drop the legend by doing show.false. Let's put this down. And so that gives us a lot more room. And I'm noticing that my columns are in a different order than theirs are. And so I would like to have mine be, obviously, in the same order as theirs, because I assume there's some reason that they put theirs in the order they did. And I'm just pausing because I'm struck by how much easier it is to compare within a body site, within a tissue type, across these 3 different time points. And I don't know why they didn't do this originally, but who knows? Maybe if they're watching, they could like leave a note in the comment, and that'd be great. Let me do something real quick. I guess I can't. All right. So one other thought that I had is to do this as a pair of facets, right? So to facet by nucleic acid, but then also to facet by site. And I think that that might look better in the long run because it's going to keep those separate, and it will also allow me to format the strips, the labels up at the top easier, right? So one thing they did here is they repeated the legend for both panels, right? Which is unnecessary. And they also said tissue RNA, tissue DNA, when DNA and RNA are already in the y-axis label, right? So I think what I'm going to do is maybe modify this a bit. And so my x-axis then will be time. And then I will do site by nucleic acid. And instead of facet wrap, we'll do facet grid. And so then I don't need the n row equals 2. And so now what we've got is, well, I faceted it in the wrong direction. So I want to do nucleic acid tilde site. And there we go. So now we have the different body sites across effectively the columns, the x-axis. And then within those, we have those time points, right? And what I want to do now is let's go ahead and start to clean this up a bit and just make it look nice, right? And so I'm trying to think about what I want to do first. So let's go ahead and get rid of this density and the time. One thing I'm going to do is I'm going to use this strip label to create the y-axis label. So let's come in here and we'll do labs x equals null, y equals null. Great. And I saw I think a contribution to the cause by Shabu. Thank you so much. That means a lot to me that you would contribute financially to this project. Thank you so much. That really means a lot. Thank you. And so now we've got that. I think we're going to go ahead and drop the x-axis labels. I could put that on like a 45-degree angle or something like that, but I think it's just going to look, that's not going to be great. And I think it's going to be obvious that it's time, and especially if we put a legend in for the time. So I'm going to come in here and remove those. We'll do that with theme, and we'll do axis.tix, or axis text dot x equals element blank. And we'll also turn off the ticks. So we'll do axis.tix dot x equals element blank. Right. So that's cool. Now let's think about, well, since we're doing the x-axis, let's go ahead and do this color, right? And so we'll come in here and I'm going to do scale, fill, manual, and insert that here. And so we're going to have 3 variables. And a trick that I learned from you all, actually, this is in values, is that I can give it a named vector, right? So I can do like 6 dpi equals, and I'll say white, and then I'll do 12 wpi equals, let's say, got my quote in the wrong place, gray, and then 66 wpi equals, I did it again, quote equals black. All right. And so now I should have white, gray, and black points. And instead I have gray, gray, and black. And so that probably means that I got something screwed up here. So this is supposed to be 12 days post-infection, 21 weeks post-infection. All right. All right. So the default color for an NA is gray. And so now you can see that we've got those 3 time points lit up by the 3 different colors. Even though like color isn't necessary here, I think color would be nice, don't you? So let's come in here and let's do like blue. And is there a light blue? That's kind of ugly. Dodger blue. What does that look like? Navy. Something like that. I think that's cool. All right, so again, we're showing time by the change in the color. And now I can come back and I'm gonna add back in my legend. Where are you? I had show legend equals false down here. And so I've got that legend, and I don't want it off on the right because that's taking up a lot of real estate. They put their legends up at the top, as you can see here. I think I'll put it at the bottom, okay? And I'm also gonna turn off the label on that. So I could do that in the scale fill manual, or I could do it here in labs. So I'll do fill equals null. And so now we see we no longer have that title there. And down here, we could do legend.position equals bottom. And so then that puts that legend at the bottom, okay? So let me know what you think about that, as opposed to having it for each of the 3 time points for each of the body sites, right? Let me know what you think, but I'm gonna roll with that. I'll come back and format the legend here in a bit because I think we still have a lot of extra space around it that's unnecessary. So let's turn our attention to the y-axis. And so we have these labels on the right side, but I want them on the left side. And I'm actually, so I'm gonna put them on the left side because I'm gonna use those to create the y-axis label. So we'll do that back up here in facet grid. And I forget the argument, and it's not gonna tell me. Is it position? No, I'm gonna have to phone a friend and do facet grid and hide my face. And so let's see. So I believe the argument is switch. Okay. So we'll do that. So we'll do switch. And there's a top label and there's a bottom, a side label. So let's do switch equals X. Again, I forget if it's X or Y. We'll find out here pretty quickly. Oh, it's Y. But if you wanted to put these labels at the bottom, that's how you would do it, right? So, but I want it to be Y. And so you can see that then puts the label on the left side rather than the right side, but it's on the inside of the y-axis. I want it to be on the outside of the y-axis, right? And so for that, we can do strip dot placement, and we can then say outside, and that's done in the theme function. And so now what we see is that we've got this label on the outside. Okay, cool, huh? Now what I want to do is I want to replace DNA and RNA with what they used for their y-axis labels, right? So I'm going to come back up to the top here, and we set those values here in bind rows, right? And so the name of, well, this DNA and this RNA on the left side of the equal sign is what's going into the nucleic acid column. So here, what I want to do instead of DNA is going to be SIV DNA per 10 to the 6 cells, right? And so let me run this just to show you what that's going to look like. And I think I said one thing and did another. Oh, Pat. That was in the bind rows. Okay, so I think I screwed that up. I said one thing, but I did the other. So it's supposed to go there. Okay, there you go. And so now if we look at this, we see that this is our y-axis label, right? And so we can do the same thing for RNA. And it's reordering the 2 facets because it does it alphabetically again, right? So DNA was up at the top because D comes before R, but now R comes before S. But if I do the same thing with RNA, we'll get the ordering that we want, right? So I'm going to go ahead and copy this and put this down. and do that. And then we'll do SIV RNA. And there we go. We have the DNA up at the top, RNA at the bottom, and we have this kind of hacky exponent for 10 to the 6. So what I'm going to do is I'm going to use element markdown from the ggtext package to go ahead and render that as a superscript. Hey, Andres, thanks for joining from Stockholm. Great to have you. So are there any people from the US watching today? I've got Europe, we have Africa, and I believe Asia I saw. I think THB, I'm not sure what currency that is. I think that might be in Asia. But anyway, so give us a shout out where you're coming from. I've got 18 people watching right now. So let us know where you are. Cool. So like I said, we're going to change this into a superscript. The caret should work. I think it's like a double caret in Markdown to make it a superscript. I go back and forth on, like, I have mixed success with doing that. Usually what I'll do is I'll use the HTML tag soup, which might be what we end up doing, but let's start with the carets. And so we'll do library ggtext. Ggtext is a great package for doing these types of text manipulations. And so then in here we'll do strip.text equals element markdown. And so this will make markdown for both the left side and the top strips. And so now what we see is what I thought we'd see. It didn't render it as a superscript. Maybe it's a single caret. I don't know. No, that didn't work. So like I said, I get mixed success in using the markdown for a superscript. So what I find is just quicker, easier is the HTML tag, like so. And I'll copy and paste this down. That soup makes the superscript. If you want a subscript, it's sub. Barrington, Illinois. Okay, John, sorry. And we've got Brazil. West Virginia. I'm sorry, Hassan, I remember. You're like the first person in, right? But that did get a number of people to say that they're joining in from the US or from Canada. So, welcome. I love West Virginia. It's beautiful. Driving in West Virginia, if you've never driven in West Virginia, is not for the faint of heart because it is a very mountainous state and the roads are very narrow and they just twist and turn all over the place. And you might look at a map and be like, wow, that's only 2 miles away. But in reality, it's like 20 because the roads twist and turn. I remember driving to a funeral in West Virginia a few years ago in like the middle of the night. And I was like, I had the air conditioning down to like as low as it would go because I was sweating. I was so stressed out driving. And I'm normally not stressed out driving, but West Virginia is a beautiful place and most definitely in the United States. All right, there we go. And that did not work. And this makes me think that I have a different problem than with those carets. And that is my strip text. And that the text on the y-axis by default is on the right. And I have it on the left. And so I think what I want to do is y left. This should work now. There we go. So now what I want to do, because I can't help myself, I don't want to put out fake knowledge. I want to replace these with the caret and see if that works. And sure enough, that worked. So the problem wasn't the markdown. The problem was the markdowner, me, right? So you can do this with either approach. And if you want it to be a subscript, I believe it's a tilde. Yeah, so that you can see as a subscript. But we want it to be a superscript, and maybe I'll go ahead and make these consistent and make both of them. I'll leave that in there in the code so you can see both ways of doing it. All right, awesome. Now let's turn our attention to the y-axis text, and it's got this like R rendering of scientific notation, but we want it to be like they had, where it goes like, 10 to the minus 1 up to 10 to the 7 or whatever. So we can do that by modifying scale y log 10, and we'll do breaks equals, and I liked their interval. So basically like 10 to the minus 2 to 10 to the 7. And so we can do that with 10 to the C minus 2 actually it's going to be a seek, right? So -2 to 7 by 1. And so now we can see that we've got all that, right? And maybe for the limit on the bottom end, I'm going to put 10 to the -2. So we'll do limits, limit. I'll do -2 to NA. And so the NA allows R to pick that upper end. And didn't like that. Oh, I put -2. 1e to the -2. There we go. And so now we have that -2 at the bottom, but it added more padding. I don't want the padding. And so let's for now go ahead and we'll do this in scale y log 10. Where'd I have you? Right, and so we can do expand equals c 0, 0. And so now we can see that 10 to the -2 is there. But I don't want to actually show 10 to the -2, right? Because that's like below my limit of detection, right? So I want everything below 10 to the -1 to be kind of like nebulous what the actual value is, right? And so my breaks, let's make this 10 to the -1, right? And so now I can see that I've got the space for 10 to the -2. It goes down that far, but doesn't go up that far, right? And I'm noticing two things. So first of all, their DNA scale goes up to 10 to the 5, and their RNA goes to 10 to the 7. Let's go ahead and see if we can't get R to use different y-axis limits for our two strips, right? And so to do that, we can come back up to facet grid, and we'll do scales, or scale equals free underscore y. And so that should free up the y-axis. And so now what we see is that we've got different y-axis scale on the bottom versus the top. The other thing we see, though, is that this top panel is using the same amount of real estate as the bottom panel, right? And so we might want to scale the size by the actual data, right? So like it would make sense perhaps for this top panel to be shorter than the bottom panel because it has a shorter y-axis. Theirs is about the same, even though, whatever, it's different. And so to do that, there's another argument in facet grid that I believe is space equals y. No, I think it's free y, right? Okay. And so there we can see now that we've got tight limits on the DNA and RNA, and we're scaling the facet to the range of the data. That's a little bit different than what they did. I'm going to leave it like that because we can always come back and turn that off later. One thing that I do want to notice, of course, is that my data, it goes up to the top edge, and I don't have a limit mark up there, right? So they go up to 10 to the 5 and 10 to the 7. So unfortunately with facet grid, you can't specify different limits, right? And so that's kind of a pain. And so a trick that I want to play with is this expand argument, right? And I'm always, I don't know, a little bit nervous about expand. And so if I, let's do scale y log 10 and look over here. And so there is a expand argument here. So let's look down at what it tells us it's doing. And let's see, for position scales, right? And so use the convenience function expansion. Okay, so let's do that. And so this is a convenience function for generating scale expansion vectors for the expand argument of scale continuous, scale discrete. And so there's expansion and expand scale. I think we want expansion. And so we can multiply or add values. So the mult is a vector of multiplicative range expansion factors of length 1. Both the lower and the upper limits of the scale are expanded outward by molt. And if the length is 2, the lower is expanded by molt 1 and the upper by molt 2. So let's try expansion with molt. So yeah, so we'll do expansion, molt equals C. And so I don't know if we want 0 or 1. So let's do 0 and 1. See what that gets us. And so 0 is right, and 1 is not right. And I'm kind of struggling here to think about what it's doing. It feels like it's doubling the range, right? Like it's going up. I don't know. It looks weird. So the 0 is right. Let's make this maybe 0.2. And so we're gaining on it, right? So I don't want 0.2. Let's bring it down. Like that 10 to the 5 would actually be fine on the top. So, but I can't control them separately. What happens if we do 0.1? That's pretty good. Because like nothing on that DNA is above 10 to the 4, as far as I can tell. And it goes up past 10 to the 7. So let's see if we can go down even further. So I had 0.1. Let's do 0.05. And so that, I would like to get the 10 to the 7 on the bottom. So let's come back here and let's maybe go up to 0.06. All right, 0.07. Trying to pick a value where I'll get 10 to the 7. Maybe it was 0.1. There we go. So that's cool. Let's do that. Okay, and so now we've got that range of values and we're not clipping any of our data, right? So now let's go ahead and change our text. Let's see, we scale y log 10. We had these breaks and we want to change the labels. Okay, so our labels are going to go like so, and I'm going to use Markdown to do this. And so maybe we'll do glue on 10 that. So this needs to be in a string. And so we'll do 10 that, that. And I think we need a closing caret, right? And then a closing parenthesis. And so this won't render, right? But that's what we've got. And so now we want to render that with Markdown. So we'll then do axis.text.y equals element Markdown. Get a comma there. Boom. It does not like my -1 for some reason. Oh, why don't you like my -1? That's weird. I wonder what this looks like when I run it. So I wonder if this needs to be in parentheses. Nope. It still doesn't like that. So again, this is what I mean about having problems using the caret versus the superscript HTML tag. So I'm going to do the soup and back out of it here. And there we go. That looks basically the way I want it to look. I think that's great. Okay. Now, let's see. So let's go ahead and start playing with a little bit of the theming. Or before we play with the theming, let's go ahead and I want to make the jitter of the points a bit wider than it is. So let's come back up to geom jitter. And here in, well, I use position jitter dodge, but I'm not using that anymore because I faceted everything, right? And so that gave me more of a jitter. And that's perhaps too much jitter, right? Like I can see up here that it's kind of overlapping a little bit. So we can come back up to geom jitter and let's do width equals 0.4. Okay, that's probably not enough. So let's do like 0.3. So that's better, that's a bit more narrow. And something that we can do is I could do position equals position jitter, width equals 0.3, and then seed equals 1976-06-20. And this way, it will be reproducible, right? Like it won't change the jittering every time, right? So now if I rerun this, nothing changes, right? So I think that's a decent jitter width. We might get some more width here, but I think that's gonna be pretty good. Let's go ahead and you'll notice that on theirs, they have a line for the median. And I'm starting to think that my blue here is too dark. So maybe what we'll do is, let's go to Dodger blue and then do how's that look? I need a different blue. And I've got an idea for doing that, but let's hold on to that for right now. So I want to draw in those horizontal lines, right? I'm going to draw in a black line, which is why I didn't want like the navy, because the black line will overlap too much with that. So let's come back and after geom jitter, we'll do stat summary. And so stat summary allows us to add a statistical summary layer to our plot, right? And so we'll do fun equals median, and yeah, and then the geom will be crossbar. Okay. And so now we can see that we've got that line going across the data. And you can see, perhaps, down here and down here, that we have a bar, the median, is below the limit of detection. Whereas over here, they removed those points and then calculated the median, which I don't think is the right way to do it. It doesn't change their story, but I don't think that's the right way to do it. So let's make that line a bit wider, but not as thick. So we'll come back up to stat summary and we'll do line weight. So line weight. Let's try 0.5, or I guess I did 0.4. It's not line weight. Line. Let's do size. 0.3. Line width. All right, that's what I wanted. Line width equals 0.5. And then we'll do width equals 0.6. Okay, so I don't think I made the line width any different, and I made it shorter, not as wide. So let's go up to 1.1. I think that's pretty decent, but let's make it perhaps not as thick, and let's take that down to say 0.3, and that thins that up a bit. And just kind of thinking about it, that like there's not as much room as I'd hoped there'd be left to right. We'll play with that, but let's sit there for now, and let's go to the color. So a nice site that I like going to for color is Color Brewer 2. So Color Brewer 2. .org. Okay, and so that gets you to this site where there's, by default, we'll say there's 3 classes, right? So we have for 12 days post-infection, 21, and 66 weeks post-infection. So it's going to be sequential. I want to be in the blues. I like those blues. So then, or maybe that's a little bit lighter. That single hue. So I'm going to then export these 3 values. You can also click on the tab here. Maybe that's what I'll do. Copy that, and then come back to RStudio. And I'm going to just throw those values here. And then I'm going to cut and paste those hex codes to replace the values I already had. Oh, and I forgot the pound. Okay, there we go. And then this. And I got an at instead of a pound. All right. There we go. And so, yeah, I think that color scheme looks better. I don't want the crossbar in my legend. I want to keep the circles. So we can turn that off back in stats summary. So here I could do like show.legend equals false. And I should get back my circles like I had before. Okay. Cool. All right. Now let's start playing with the theming. And let's go ahead and remove the background and add our axis lines. And so we'll come back and I'll do panel.background equals element blank. And I want to look back at there's no grid lines. So let's roll with that. And we can also make sure there's no grid lines. So we can do like panel.grid equals element blank. All right, so you can't see the grid lines, but they're gone anyway. We want to add axis lines, and we want to make our ticks probably a little bit thinner. So I'll do that down here. We'll do axis.line equals element line, and we'll do line width equals 0.2. And then I'll do axis.ticks.y equals element line, and I'll do line width equals 0.2. And I have another axis ticks argument down here, so I'm going to just keep those together. And so now you can see that we've got those lines. That looks pretty good. Sometimes people with a facet, they want like an x-axis line for both of the facets. So I don't do a lot of this, and so I think the you learn best when you force yourself to retrieve it rather than going to look for the crutch. So I think here I could do axis equals x. Nope. So let's do all x. Nope, that didn't do it. So, all right, facet grid. Facet underscore grid. We'll get the help. So it's either margins or axes. And I don't think we want margins. I think we want, what does axes say? Oh, maybe what I put in was axis rather than axes. So let's look at axes. Determines which axes will be drawn. When the default margins, it'll be drawn at the exterior. If you put all X, then it'll draw those. So I think my problem was that I wrote axis rather than axes. And so when you write axis, it's assuming that you meant axis labels, because the only thing that starts axis is axis labels. So that is something, yeah, that's sure enough what I did. So if I turn that to an E, we get our axis line, right? So I think that's nice to kind of help separate things a bit. Cool. All right, let's now clean up our facet strips. And so I want to definitely get rid of the background, and I'm going to want to put some line breaks in these labels and also get them in the right order. So let's work on the order first. So we'll come back up, and the way we will do that is by setting the sites as a factor. So down here, when we did separate wider, we have site. And we want to mutate that. And we can do that down here in this mutate statement, right? And we'll do site equals factor on site. And then my levels are, well, I had a vector sites, right? Maybe, but I don't have the blood in there, right? And so, yeah, we can deal with that. So let's come down. Sites. And now I'm forgetting if peripheral blood was capitalized. Yep, it's capitalized. Okay. So this then should leave our sites in the order that we had them originally, which is what was in the original publication. And so now what we can see is we have peripheral lymph node, mesenteric, spleen, all the way over, and it doesn't have blood. So I screwed up blood. Which makes me think I misspelled it. Oh, I actually misspelled it originally. Peripheral blood and peripheral blood. All right, so now we have peripheral blood first and then those others. Okay, so what we want to do is we want to fold those over multiple lines. And one other thing we can do is that it's clipping the text to within that cell, right? And yeah, so we can turn that off. So we could do like strip dot clip equals off. And so now we should see the full label, but it's going to run into everything else, right? Like that. And so let's go ahead and put in some line breaks in those names. And we'll do that back up here in sites. And so maybe I'll do it like this. So I have to use the HTML tag for a line break, which is BR. And so we'll do this, bone marrow. And then we also want to do peripheral blood, which means I have to do it a couple times. Probably could have done that a better way, but whatever. And, oh, well, so it didn't render my HTML, and that is because I didn't set up strip text X to be element markdown. So strip text X element markdown. All right. So, so I'm still running into this problem where it's not using my HTML. So let's come back to the beginning. So I had sites. Oh, I probably didn't run sites. I probably didn't run all the code. All right, let's rerun all the code. And there we go. Now we have that. And so we still have a little bit of overwriting of the different columns. And like duodenum, you can see, I'm not so concerned about duodenum because bone marrow and rectum are shorter and no one's gonna have problems. Whereas here with like the peripheral lymph node and mesenteric lymph node, those run into each other. So I could increase the spacing between the panels, but I don't want to do that. And so what I'll do instead, I think, is decrease the size of the font. And so here then, let's do size equals 7. And so that brings that down. And I think that looks good. If we went up to 8, again, it's overriding. So let's stick with 7. I think that's good. Let's also maybe make our y-axis text a 7-point font. And so that was axis text y. And so let's do size equals 7. And so that shrunk that, and it made things a bit broader. And I think maybe what I'd also like to do is decrease the margin around the strip, right? Because I'm trying to get away to have a wider plot, right? And so that's the strip text X left. And let's do margin equals margin, zeros all the way around, right? And so we can see that we had more padding around it. I'm going to turn off that gray, don't worry. And that pulls that apart a bit more. And I wonder if we can maybe decrease the margin between the text and the numbers. That might be, I don't know. So I think that's the text, the axis text Y. We do like margin equals margin, again, zeros all the way around. I don't think that's what I want, but. So that did something. That got the right hand. That didn't do anything to the left. It did stuff to the right. So I'm going to, I think, turn that off. And I think that's good. That strip spacing around it, like there is still spacing around that I'm not totally sure where that's coming from, but I think it's okay. I'm not going to worry about it. Let's go ahead and remove, let's remove that background. And so we'll do strip dot background element blank. And that goes away, which I think looks pretty nice. Let's now think about our legend. And I want to decrease the space between, so like the point kind of hovers in the middle, and I want it to be closer to my text. And so I'm gonna turn on legend background, and I find that working with the legend and spacing is not super intuitive to me, and I'm trying to develop some tricks to make it easier. So if I turn on the background, what am I doing? All right, save. There we go. So we can see like the margin around the legend. And so let's see if we can reduce that margin. So we'll do legend.margin equals margin, and I'm going to do zeros all the way around and see what this does. And so, okay, so that made the box tighter, and I believe looks like it has a margin on the top because the key, the item in the legend is being made tall. So we could then do legend.key height takes unit. And so here, let's do like 8 pt. Yeah. So then that shrunk that down further. And I think that is good. Let's then play with the spacing. So like the width of that. So legend key width. What happens if we do 4? Or yeah. So that you can see brought that in. And then we could do like legend dot text dot element, text, margin, and we'll do margin on the right. Let's make that like 3. So that made the left 0 and the right 3, because you can see the text is basically right on the point. So let's go ahead and do, say, right 5. Let's do L2. Maybe we can have more space than that. Let's do like 3 and 7. My finger works. All right. So I think that looks pretty good. I would like to move that up closer to the bottom line though. And so I think here what we can do is like legend dot, just kind of look at the other arguments. I thought there was like a legend box spacing. So I think that's what we want. Box spacing. This is spacing between the plotting area and the legend box. So let's do that. And we'll do unit. And let's do like 3 points. And so that, again, brings that down pretty nice. Now I'm going to turn back off that legend background. Well, maybe I'll comment it out. And so then that cleans that up pretty nicely. What do you think? There's one thing I'm missing, and that is my limit of detection. So let's go ahead and work on that now. So the limit of detection, I believe, is at 10 to the minus 1. And so I want to do that. And I also want to add some jitter to these points that are basically on top of each other. So we can add the line by coming back up, and I will then do geom h line. We'll do y-intercept equals 1e to the minus 1. Do color equals gray. I'll do line width equals 0.2. And so there's our line for the limit of detection. And maybe I'll put an annotation on top of that. And so I'll come back up here and I will say annotate, and we'll do geom equals text. And then we'll do label equals LOD. So then the X, the Y. So the Y is going to be like, let's do 1e to the minus 1. And the X, I believe this is 1, 2, 3. And so if I put it at 1, it's going to be there. So maybe I want to move it over. So like 0.8. And it's not exactly what we want, but it's a good place to start. And I think I've got one too many parentheses there. Oh, and I misspelled annotate. Someone was probably yelling at me and I just couldn't quite hear you. Yell louder. All right, so there we go. We've got our LOD. It is being centered at that point, and it's then getting replicated across all of the panels. And so let's see, we can do layout equals 1 and 8. Okay, so this is panel 1. I believe this is panel 8. If it's not 8, then it's 2. And so if we do layout 1 and 2, then it should only show up on those 2 panels. Okay. I guess it's 1 and 9. Close, so close, Pat. Yeah, 1 and 9. There we go, 1 and 9. Right. I just can't quite count that high. So we want to shrink the font, and we want to, so we'll do size equals, let's do 7, and we'll do size.unit equals pt, layout 1 and 9, and well, we also make the color gray, so it matches the line. And we also need to do the justification. So we'll do HJust equals 0 to make it left justified. Okay, and so that's cool. It can move to the left a bit. And so let's try 0.5. Yeah, I think that's good. Let's move it up. And so we could move it up with vertical justification. So we could do VJust equals 0. And I always screw this up. It's either 0 or 1. Oh, that wasn't so bad. But it's right on that line, right? So I think what we could do would be like, is it 0.1? Nope, that didn't do it. So let's do like negative 0.1. And that moved it up. Let's go up maybe negative 0.2. Right? And so that puts that LOD right on that line. I guess we could say, like, do you want to write out limit of detection? I wonder what that would look like. I feel like that would just be kind of heavy. Yeah, it's getting clipped. We could fix that clip, but I think that's too much text. Let's go back to LOD. There you go. I think that's cool. Let me know what you think. I think there's a lag between me presenting and your all's comments. So just want to see if I'm missing anything. Okay. So I think the last thing I want to do is to jitter these points vertically, right? And so something that I had done was back up here with your all's help. We did the NA replace. And where was that? Huh. Why aren't I seeing it? Oh, replace NA, right here, right? And so I replaced all of the values below the limit of detection with 3e to the minus 2. And so what I'd like to do is to replace that with a random value, maybe between like 2e to the minus 2 and 4e to the minus 2, right? So this I will comment and bring it down. And so what we could do would be like run if, right? So if I do run if and do run if, I want one value, 2e to the minus 2 to 4e to the minus 2, right? I'm going to get that value. And if I do that a bunch of times, I get a bunch of values, right? Oh, there you go. And so that's going to be that random position. But if I do it like this, then it's going to probably be applying this same number to all of the values that I have NAs for. So what I'm going to do instead is do density, and we'll do a map. So do map dBl, I believe. And we're going to do that on density. And we're going to replace NA with this runif statement. Okay. And so basically the problem is that run NA with runif isn't going to be vectorized. And so we're going to have to use map to vectorize it for us. And so I need to put a tilde in there because I'm using all these arguments. And so what this is going to do is it's going to go each line of density. That's what map does. It's going to take each value in the density column. And separately, it's going to say, if density is NA, then we're going to replace it with this, this random number we generate. Okay, so I'll go ahead and get rid of that. This should work. No, of course it didn't work. Why didn't you work? Probably because of parentheses. Yeah, parentheses. All right. There we go. Ah, we have an error. So I'm trying to run everything all at once, which is, I don't know, it's great when it works, but if it doesn't, then you're like stuck scratching your head of what happened. So let's go ahead and run those lines. And it is complaining. Oh, so I put density in here, and what that should be is .x, because this is the .x argument. Hey, it worked. What do you know? And there we go. We now have jitter, vertical jitter on our points, so we can get an idea of like how many points are there. One comment that came in to the critique video was that someone didn't like in this was that the points, it was really hard to see how many points there were, right? So there's 24 animals. So every column here is 24 points. So you kind of know that. But visually, something we might try is to perhaps shrink the size of the point as well as the stroke, the border around the points, and then maybe make it wider. So let's see if that would work. We could also try the alpha. Maybe we start there. So let's do like alpha equals 0.2. And that just doesn't look good to me. If we do like 0.5. Oh, and I think I lost my comma. Yeah, I also don't think that looks very good. So let's take out the alpha. And let's do like size equals 1. So that made them smaller. Maybe 2. Well, let's reduce the stroke also. So we can do stroke equals 0.2. And so that makes that border smaller. But then I think that makes those points also too small. So we'll end up adjusting both, right? So let's do size equals 2. Okay, that's too big. Let's do 1.2. I don't know. Let's take it up a bit. I don't like it when the points are like super small. So let's do like 1.5. And I think that's pretty clean. And maybe what we could do now, what happens if we reduce the stroke? If we go to like 0.1, so that's pretty clean. And I'm wondering if we can get to a point where we can increase the width of the jitter a little bit, but I feel like maybe not. Yeah, I feel like maybe not. But I think that, let's try. Why not? I've talked about it. Let's do it. So let's go up to like 0.4. Yeah. That's cool. Kind of, I think again up here the points are running into each other though. So maybe we can split the difference and do 0.35. Yeah, I think that's still too close for my comfort. So let's go back to 0.3. And yeah. One other thought I had was on the panel spacing. So we could do panel.spacing x. Let's do unit. Let's try 3 points and start there. So that removed some of that spacing between the panels. again, gave us some more space. I think the jittering is scaling with the amount of room it has. So I think that's pretty good. I'm happy to stop there. I think, again, the chat and my talking has gotten a little bit out of sync, so I'm sorry if people have questions along the way or wanted to make comments. Feel free to leave comments after you've watched this, and I'm happy to answer questions later. Let me go ahead and put these two versions next to each other. So again, my goal in doing this was to combine panels D and E into the same real estate that they occupied in the original figure, right? And so, let's see, something like that, right? And so the same real estate, and I wanted it to do a better job of telling the story that the authors wanted to tell, right? And so the story that the authors wanted to tell, again, from their text, if I go back to that text, right, was that the RNA on treatment declined 3 to 6 logs and the DNA 1 to 2 logs, right? And so here, that's so much easier to see, I think, right? That you go for each of these sites and you can see, like, yeah, that's a 1 to 2 log drop. That's about a 1 log drop. That's about 1 to 2 log drop, right? Like, you can see that very easily without having to scan back and forth across the points. Whereas again, here, you're gonna have to take this column, compare to this, and kind of go back and forth. Whereas here, again, I can just take any of these sites and much more easily compare it. And again, for the RNA, you see that 3 to 6 fold drop as well, and it's much easier to detect. The other thing that they had done was that they reported the medians, but their medians did not include the animals that were below the limit of detection. I've included those, right? And so I think that's, in a way, like a more honest representation of the data, because if you're calculating a median, that's a rank-based thing, right? Whereas like the mean, you'd have to say it's 0, right? But what I'm saying with median is that like these 3 or 6 or 8 values are below everything else. And so, you know, even in the case where we've got the median being below the limit of detection like this, it's at the limit of detection, right? They're below the limit of detection like that, right? So, I don't know. Let me know what you think. The one thing about this that I kind of don't like is how I'm representing the time, right, with this legend. Let me know what you think of it. And I just think that if I were putting in 12 DPI, 21 WPI, 66 WPI for all 8 or 16 panels, that just gets really cluttered and busy. Whereas I think people can say like, okay, these are 3 different time points. As we get more blue, we're going further into time, and they can see that change. Let me know what you think. I don't know. I think mine's also prettier. I don't know. I really liked how this came together. The one thing that they've got that I don't have, and that I'm not gonna get there, and it might explain why they pulled things apart with the blood, is that they do have the p-values here, right, to show this differences in significance. As always, they have way too many significant digits to the right of the decimal point. If you're going out to 10 to the minus 7, it's really unnecessary. And I don't know, I think it's pretty obvious that there's these big differences, right? Like, I think you don't need statistics to know that with RNA, things dropped, right? Like, the distributions don't even overlap. So anyway, I don't know. That's something that maybe you could work on your own. I think also there are definitely going to be some things in here that aren't statistically significant, like peripheral lymph node between 21 and 66 weeks, or duodenum between 12 DPI and 21 DPI, right? But I think, again, qualitatively, you certainly get the sense that there's this fall off in viral load, both as measured by DNA and RNA, in a much clearer way of representing the data. All right, well, that's all I've got for today. Hopefully you enjoyed this and enjoyed walking through the code as I developed it. I will be posting that code. Look down below in the description for a link to where that you can find that code. Very grateful for the financial contributions that people made. I see that we do have Kenya represented. Awesome. And so it's great to have that worldwide distribution of people tuning in. As always, if you have ideas or figures that you find out in the wild that you would like my reaction to, or that you would like to learn how to recreate, shoot me an email, leave a comment to any of the videos, and I'll follow up. And I would enjoy doing that. Otherwise, you're going to get stuff that I come up with, which may or may not be relevant to you, but hopefully highlight some of the kind of trends that I'm seeing in data visualizations that people are publishing in journals that are very highly regarded, like Nature and Nature Microbiology. All right, well, that's all I've got for today. Please tell your friends what we're doing here, and I will look forward to seeing you next time for another episode of Code Club. Take care.